Hi, students, and welcome to Chapter 1, Section 3, Thinking Like a Scientist. We'll look a little bit here today into the scientific method and how scientists think. So when we're thinking about this experimental approach to science, a little bit of background on the word chemistry. It comes from the word alchemy, and alchemists were people who were searching for ways to change metals into more profitable metals. So they were looking to develop tools and techniques to work with these metals and change them into something that they could sell for a little bit more money. So that's where the word chemistry comes from. The word alchemy means to change metals. Alchemists are the ones that designed the beakers, the flasks, the tongs, the funnels, and the mortars and pestles, which are used by chemists today, and that you would see in a chemistry lab. Antoine Laurent Lavoisier, living in the late 1700s, he's someone who helped transform chemistry from a science of just observing, phenomena and other observations into actually a science of measurement that we know of today. So some chemistry tools will actually be named after him, Lavoisier. He's known for developing a balance that could measure mass to 0.0005 grams. So he measured a very accurate balance to actually measure mass in grams. And he was also able to show that oxygen is required for materials to burn, which again, seems like common sense. But if you think about that, he was in the late 1700s. These were two items that were really important for later development of chemistry concepts. That brings us to the scientific method then. We'll spend a little bit of time talking about that. The scientific method is a logical, systematic approach to the solution of a scientific problem. It involves making observations, proposing and testing a hypothesis, which is kind of an answer or a guess to an observation or question, developing a theory for how that could be so. So let's go over kind of these specific steps of the scientific method. Making observation is when you use your senses to obtain information. So either through sight, through smell, through touch, through taste, through hearing, you're making some sort of observation about the world around you. The scientific method then is testing the certain hypothesis. And a hypothesis is a proposed explanation for an observation. So let's say you observe something in nature, like trees are green. Your hypothesis would be a proposed explanation for that observation. So your hypothesis would be trees are green because they go through photosynthesis, or trees are green because they refract light. So you need to develop a hypothesis, which is a proposed explanation for an observation. Testing the hypothesis. So then scientists are able to test their hypothesis, which again is that proposed explanation, through experiments. And an experiment is a procedure that is used to test a hypothesis. It usually has variables or factors that can change. These variables are called, one is usually an independent variable, such as a variable that you can change during an experiment. So this isn't a variable that you can control to test out your hypothesis. So independent variable means that the variable that you can change. That's very important to remember. The dependent variable is the variable that is observed and that does not change. So again, testing a hypothesis goes through this step of developing an experiment, and experiments usually have variables or factors that can change. The independent variable is the variable that you change during an experiment, and the dependable variable will be the variable that will be observed during an experiment. More testing of a hypothesis for the results of an experiment to actually be accepted by scientific community and in journals. You guys are working on a literature review where you're reading about experiments that have been peer-reviewed to make sure they can be accepted by the scientific community. The experiment has to be repeatable with the same results. So you have to be able to conduct this experiment many times and get the same result in order for that experiment to actually be accepted by the scientific community. And then when scientists publish their findings in scientific journals, which you guys are reading about, they need to include their procedures as well as their results. So you're probably reading through a lot of procedures in these scientific articles of how they're doing the experiments, a lot of words, a lot of numbers that you might not understand, but they have to include specific details of the procedures as well as specific details of all the results in order for their hypothesis to be tested and then eventually accepted. More about testing the hypothesis. Sometimes the experiments are too complicated, so a model is used to gain more understanding. And a model is what we call a representation of an object or an event. Chemists will often use models to study different chemical reactions and different processes. So that is what a model is. Developing theories, once a hypothesis meets the test of a repeated experimentation, it may become a theory. And a theory is a well-tested explanation for a broad set of observations. So if something becomes a theory, it's been well-tested many times over for a broad set of observations. Theories may need to be changed in the future to explain if there's a new observation that occurs or any new experimental results that occurred that were different from before. All right. Then scientific law. If something becomes a scientific law, which few things are, most are scientific theories, a scientific law is a concise statement that summarizes the results of many observations and experiments. There's a little cartoon there. I was a drifter. They got me to find the law of gravity. The law of gravity is one example of a scientific law that has been proven. Because every time you drop something on Earth, it will land at 9.8 meters per second squared. So that is a scientific law, the law of gravity. This flowchart below shows how scientific experiments can lead to laws as well as to theories. So through the scientific method, we make observations, which will develop into hypotheses, which a hypothesis may be revised based on data. A hypothesis will lead to an experiment, and an experiment can lead to other observations that support the hypothesis or disprove the hypothesis. A theory is formed when a theory is tested by more experiments and then modified as necessary. And then a scientific law will summarize all the results of many, many observations and experiments. And the law of gravity is an example of a scientific law. So a law does describe a relationship, and a theory kind of explains the relationship. So if we're looking into the scientific method here, we go from a hypothesis is the prediction to the experiment and observation, which gives us to a result, which in a body of knowledge that is used to form a law, which is kind of like a summary, or a theory, which is the explanation. Collaboration. Scientists choose to collaborate with each other. Some research problems are so complicated that one person doesn't necessarily have all the required skills on that knowledge and all the resources to solve the problem. So they'll collaborate with other scientists. For example, a chemist and a physicist might come together, or a chemist and a biologist might come together. So collaboration is very common. More about collaboration. Working in pairs or in groups can be challenging, but it's very rewarding. So that's why often in these journals, you'll see several authors that are authoring many of these scientific articles in the journals. Research groups will communicate face-to-face. Some scientists will communicate through email, Zoom, by phone, or at local or international conferences. So many times, scientists will go to the conference and present their material so that other scientists who are interested can learn about it or help in the future. They also can publish their work in scientific journals. And again, that's what you guys are reading for your literature review for your first lab. Scientific journals are the most reliable source. Articles in these scientific journals, it's very hard to get published. They are reviewed by experts before they're published. And if there are any errors in the experimental design or challenges of a conclusion, they will be discovered, sent back to the author, and then they must be taken care of. Anything that is not good science, or there's, experiments or the results that do not show everything, they will not be published. So it's just a very good way to make sure that these articles are being peer reviewed, and anything that's getting published has been reviewed many, many times over by experts. And here are some examples of some scientific journals. And again, you guys are reading through those for your lab and literature review. So that's section 1.3, and I'll see you for section 1.4. Take care, everybody.